at this point, we've reached the end, at least temporarily, of the Modern Java by Example webinars. Let me tell you what's coming next, though, if I can share my screen again here. And you'll understand, hopefully, why in a second, why there's a new thing that's coming along. So let's see. Let me share my screen. So starting in about 2 weeks, I'm going to be teaching a new course at Vanderbilt. And the course is, of course, kind of for not beginners, but people who are like sophomores, perhaps. And it's a course on advanced C++ and generic programming and software patterns. That's basically the course. I'll show you a link to the website in a second. And so in preparation for that, I'm going to be starting a new webinar series starting this Monday on basically C++ standard template library. So it'll be similar in the theme to what we've been doing here, except it'll all be in C++, not in Java, and it'll be focusing primarily on standard template library abstractions like containers, algorithms, iterators, functors, those kinds of things. And I haven't got everything finished yet. I've got a little stub of a playlist, which is where everything's going to go once I've got a chance to finish up my website. You can find all the examples that'll be part of this webinar series here in my GitHub repository, in my C++ folder. I've got a bunch of stuff in there already. I'll be adding more things over the next week or so as I start up. And this is actually part of a class that I teach at Vanderbilt. I haven't taught this class in a while, but for a variety of reasons, not the least of which is that a lot of students have been inconvenienced by the coronavirus pandemic. We're going to be offering some summer courses this summer, and I'll be teaching them. And while only Vanderbilt students can take the course and get a grade and do the assignments, I'll be posting all my slides and videos to my website like I always do. And here is the course that I taught probably about 5 years ago at this point. So this is a bit dated at this stage, but I'm going to have all kinds of cool new stuff. And there'll be lots of discussions about C++ STL, generic programming, lots of discussions about software patterns. We'll be going through all the Gang of Four patterns, the patterns from the design pattern catalog, the object-oriented reusable software architecture book by the so-called Gang of Four. So this is sort of older stuff that I did a while back, but feel free to follow along if you're interested. Feel free to join the webinars next week if you're interested in learning about C++. There probably won't be much concurrency here in this course. It's not really designed for people with that. It's for more people who are more junior than the seniors and grad students I normally teach my classes for. I actually did go out online and look up to see whether or not there's reactive C++. And in fact, there is reactive C++, which I thought was pretty cool. So there's actually something called RX C++. So if you go to the RX C++ website, you can find lots of stuff about RX C++. It doesn't appear to be quite as active as the RX Java stuff. And of course, I would suspect that things like, RX for .NET and so on. But there is stuff out there. And but one thing that caught my eye, I did a little bit of poking around the other day. I don't know if I can find this. I found some interesting tutorials that showed some examples. And this is one of my complaints about modern C++. The code just gets so impossibly hard to understand because of some of the newer features. So there was also another interesting thing. I can't find it right now, but someone had done some interesting experiments where they showed that the overhead of putting C++ into reactive style programming is astronomical unless you do some kind of weird, quirky uses of C++, avoiding the use of value semantics of your types, which I thought were kind of at odds with what C++ is about. So C++ may or may not be the best language for reactive extensions, but if I have some time, I'll play around with it a little bit. But my class is primarily going to focus on STL and generic programming, which is very well established, and there's lots of cool stuff you can learn about that. So I think there might be another couple of questions, and then we'll wrap it up. Let's see. Any boot camp webinar on Java to C++ migration? Wow, that's a great question. It's one of those funny things. It's actually, let me try to see if I can get this straight. So going from Java to C++ or from C++ to Java is deceptively simple at first because the language has very similar syntax. A lot of the operations are the same, at least originally. But the minute you start looking at it carefully, you discover that there's a lot of divergence. And so the single biggest problem when people come from Java to C++ is that they tend to write code with lots of memory leaks because Java has a garbage collector and C++ doesn't really have a garbage collector. So they tend to allocate a lot of objects dynamically and then they get garbage galore. Also, C++, especially modern C++, is really into value semantics. And so copy by reference, which is kind of what Java does, is not what C++ does. So that's a big shock. People who come from C++ to Java are also often very frustrated because of the lack of some of those features like pass by value. But it's not that hard. I've been programming with C++ since 1985 or so. I started programming with Java in 1995 or so. I find myself fairly fluent with both languages these days. Although, again, to be honest with you, that Java seems to be a little bit more focused on readable code. In some sense, modern Java inarguably more readable, whereas modern C++, if you're not careful, can become just a big mishmash of lambda expressions and overloaded syntax operations that are really hard to follow. So I'm probably more of a sort of a C++ 11 kind of person than a C++ 14 and beyond person. But it's a fun language. It's really cool, especially the whole concept of template programming and generic programming. That's really interesting. Java does some of those things, but unfortunately, Java's templates are so lame that, or generics are so lame that you can't do a lot of the stuff with Java that you'd love to be able to do, which is very easy to do in C++. So it's a different mindset in a lot of ways. But the good news is it's not too hard to migrate from one to the other. If you want to know a course, though, to learn how to program with Java, I actually can help you with that. Let me do one final thing here. Share my screen. So if you go to Android App Development Coursera, I think is right here, there's a course that I put together with some colleagues a number of years ago. It's actually a specialization, so it's got a lot of courses, a lot of MOOCs, massive open online courses. And this particular one starts out with a course called Java for Android. So if you're just looking to learn about how to program Java, this free course is kind of a boot camp course. You could consider taking that, and that'll probably get you up to speed pretty quickly. We just went ahead and added some cool new stuff, so it should be modernized with later versions of Android. This particular course has really no dependencies on Android. It's really all about Java, but it's Java for Android, so you can write Android applications. So if you want to kind of get a feeling for, core Java classes, control constructs, data abstraction concepts and features and so on, you might want to take a look at this. I do some of the lessons, my colleagues do other ones, and they're very talented teachers, so I think you'll enjoy the class. Okay, so I think that's basically it. Thank you guys all so much for coming for so many weeks, and I will probably pick this topic up again once I'm done with the C++ stuff, because I have lots more things to explore with reactive streams and Java and Webflux and microservices and so on. And so hopefully we'll get a chance to do more stuff in the future. But thank you very much, and I hope our paths will cross again soon.